Okay, final investment method, part four, I think, or five. I th I think four. Okay, I think four. So let's see. Um, the goal is to calculate the precise rate of return. The discount rate is something that we will include in this method, which will allow us to actualize our cash flows. Once again, actualize is like the same thing as in the previous method with the NPV, where we have these future streams of revenue and we want to know the present value. And the discount rate will be the opposite of the compound interest. So this is the same thing. But right here, we want to find a certain rate of return. We will have to find it by trial and error. You will see how this works. But the goal is to keep the NPV equal to zero. So this looks strange, but this will also look very alike the previous method, the NPV. But right now, we want to have the NPV equal to zero. We don't want it to be negative. We do not want it to be positive, just zero. Which sounds strange, but if this is the case, well, this is your internal rate of return. That's just it. Okay, you will see how this works right now. So this is the formula. Your investment is equal to the total amount of cash flows. So this strange number is just like the total amount of cash flows times your u, which is 1 plus I to the power of the minus n. Once again, this is the discount rate where we go back in time, right? Remember? But how does this work? Let's take a look. Um, this, once again, looks very much like the previous exercise, right? Um, So imagine, in this case, these are different numbers, different from mutual paint and verpaint, by the way. Imagine that in the first year over here, you have already apparently a cash flow of 2000. You will try to bring everything to today. Apparently, I wrote down vandaag instead of today. Don't ask me why, but it happened apparently. So you will use your discount rate to bring everything back to the day. This is the same thing we did in the NPV method. So the very first number will be 2000 because we already are at today. So 2000, then something will happen over here, and same goes for the other ones, right? Now, the problem is that in this exercise, you do not know your R, okay? But in the method with NPV, we were looking for NPV and we know our R. Now our NPV is 0, and the R will be our unknown variable. And as you can see, the very first number is 2000, which is like a number we do not have to bring back because it's already today, right? Then we have to multiply this number 1000 with the u to the power of a minus n. But the thing is, right now, I don't know my return because I'm looking for it. That's the whole thing. I'm looking for r. So right now, this value is unknown. And as you can see, for the second one, third, and fourth one, r will always be unknown, but it's the only unknown variable there like is. So what can you do? You can guess. You can guess, you can use trial and error. You have to find a certain r that will give you a total amount of 0 in the end. And if you try a bit, like if you try with, if you put 15, for example, like 0.15 for every r, you will get like 1,983 euros, right? Um, so this will not give you 0 in the end. So somehow you have to subtract this from this 2000 so you can find 0. But as you can see, you guess a little bit. 14% apparently is not great. Over here, 14.5 will almost give you the thing you need. But as you already can feel, this is quite annoying to calculate. So after looking for a while, and this can really be like a while, you finally get the perfect rate that will give you an NPV of 0. So here are the solutions. I think you already understand that you will have to use ICT or an Excel file to find the internal rate of return. Okay, um, that's actually it. And then you see that Mutual Paint has the highest internal rate of return, which is the best. So Mutual Paint will win once again. So thing is, during the exercises, I will show you how to calculate this using Excel. So please do not try to find the R on your own. You can try, of course. It's well, like I said before, it's a little bit of guessing, but in the end, you will manage to find it, I think. Um, but this is how it works, okay? Just know how the formula works. That's the most important thing. And once again, it almost looks the same as the NPV one, like the previous video, but right here NPV is 0 and R is the unknown variable. That's the only difference with the previous video. Now, the conclusion of all of these methods, so the payback method, the return on investment, the NPV, and the IRR, well, if we bring them all together, we can see that every single time Mutual Paint has better numbers because payback time, the shortest time, was the best. That's why Mutual Paint wins. For the other three, the highest amount wins. So Mutual Paint always wins in these cases. But the thing is, these numbers, they look very good for Mutual Paint. But the thing is, we saw, like I think in the first video about this part, that there is more to it than just these numbers. You also have like the total cost of the investment. How will you invest? Mutual Paint, do they deliver quality, or are they just like cheaper? There is more to this than these numbers. Just to remember that. But if you know nothing but these numbers, then Mutual Paint will clearly be the winner. Okay, as you can see here, Mutual Paint wins. Okay, that's it for this video at least. In the next one, I will deal with the exercises, so be prepared for that. I hope you understand the methods. Please remember how every single one of them can be calculated. Do not mix them up, especially the two last ones, the NPV and the IRR. They look alike. But the greatest difference between the two is that with the NPV, you were looking for the NPV and given your interest rate. For the IRR, the NPV is always 0 and you are looking for your R this time. That's the difference. Okay. The other two, payback method, return on investment, are very easy to understand, I think, and you cannot mix them up, in my opinion. Okay, until the next one, where I will talk about the exercises. Bye.